I will be discussing the problem set matrix 0. The problem statement says, given an m into n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it in place. The challenge of this problem is to correctly identify all rows and columns that should become 0 without accidentally losing information midway. For example, turning something into 0 too early and incorrectly causing more zeros. The final output should be the transformed matrix where all such affected rows and columns are fully zeroed. We can see we have a fixed amount of rows, let's call that m, and fixed amount of columns n. The worst case scenario, we need to make sure that every row and column is set to 0. We need to iterate through every single value in our input. Let's not update the copy. We actually don't need the copy, we need less memory. We can have one array for the number of columns and one array for the number of rows, and we can mark whether we want to fill in zeros or not, and then at the end we can actually fill in the zeros in our input array without even needing a copy. The solution code uses the first row and first column as markers to track which entire rows and columns should be zeroed, so everything can be done in place without extra memory. First, it scans the matrix. Whenever it finds a 0, it marks the corresponding column by setting matrix of 0 C is equal to 0, and the corresponding row by setting matrix of R0 is equal to 0. However, if the 0 is itself in the first row, it can't use that same row as a marker safely. So a separate boolean row 0 remembers that the first row must later be zeroed. After marking, we do a second pass starting from cell 1, 1, skipping row and column, and any cell whose row marker or column marker is 0 gets set to 0. Then we separately handle the first column. If matrix of 0, 0 is 0, it means the first column needs to become 0, so we zero it out. Finally, if row 0 W was set, we also zero the first row. If this activates the entire desired effect while using constant extra space, the time complexity of this problem is big of m into n, and space complexity is big of 1. So the patterns which are observed while solving this problem statements are matrix traversal pattern, second is in place modification without extra space, third is marker flag technique, fourth is using existing structure as storage, first row and column as markers, next is two pass algorithm strategy, next is boundary and edge case handling, first row column separately, next is dependency ordering, mark first and modify later. The last is space optimization mindset, where we use big of 1 extra space thinking.